Hello students, welcome to the course Object-Oriented Software Engineering. In today's session, we will understand the importance of object-oriented thinking in software development and get an overview of the concepts that we will study throughout this course. Before learning software engineering, let us think about the software application that we use every day. Can you identify different types of software available on a computer system? These software products can be broadly classified into system software and application software. System software controls the internal operations of a computer system. Examples include operating system, device drivers, firmware, and utility software. But application software is designed to perform specific user-oriented tasks such as web browsing, database management, online banking, enterprise operations, sales, and marketing activities. Software engineering offers a wide range of career opportunities. Professionals may work as developers, testers, analysts, architects, technical leads, product managers, data scientists, trainers, or network administrators. Each of these roles contributes to the successful software development and maintenance of software systems. Object-oriented analysis and design, commonly known as OOAD, is a systematic approach for analyzing and designing software systems using object-oriented concepts. Instead of concentrating only on functions, OOAD focuses on modeling real-world entities as objects and studying their interactions. Before OOAD became popular, software development mainly relied on procedural approaches, structured analysis and design, and case tools. Although these methods were useful, they became difficult to manage as software systems grew larger and more complex. Traditional approaches focuses mainly on procedures and functions. In contrast, OOAD combines both data and functionality into objects. This reduces redundancy, simplifies maintenance, improves software quality, and decreases development complexity. It is one of the major reasons why object-oriented approaches dominate modern software development. The major advantages of OOAD includes higher level of abstraction, better code reusability, easier adaptation to changes, improved robustness, and easier maintenance. These benefits make OOAD suitable for developing large-scale software applications. Object orientation is a problem-solving approach in which software solutions are modeled based on real-world objects. Every object contains properties that represents data and behaviors that represents actions. Objects with similar characteristics are grouped as classes. Consider vehicle as a class. Car, bus, and truck are objects created from this class. While each object is unique, they share common characteristics defined by the vehicle class. A vehicle contains properties such as color, vehicle number, seating capacity, and model number. It also performs functions such as starting the engine, stopping the engine, loading fuel, and displaying meter readings. This combination of data and behavior forms the foundation of object-oriented programming. In programming, classes act as blueprints. For example, a vehicle class defines common attributes and methods, while car, bus, and lorry objects are created from that particular class. Similarly, a student class can be used to create multiple student objects, each storing its own data. When objects are created, memory is allocated separately for each and every object. Although all objects are based on the same class definition, each object maintains its own set of values and references. Object-oriented principles. There are four fundamental principles of object orientation. They are abstraction, encapsulation, inheritance, and polymorphism. Let us briefly understand each one. Abstraction. Abstraction means focusing only on relevant information while ignoring unnecessary details. For example, in student mark management system, such as roll number, courses, and marks are important, whereas the height, weight, hobbies are generally not required. Encapsulation. Encapsulation is also known as data hiding. It combines data and methods into a single unit. It protects the data from unauthorized access and improves software security and maintainability. Inheritance. Inheritance allows one class to acquire the properties and methods from another class. This promotes code reusability and reduces development effort. A child class can inherit the functionality of parent class without modifying the original implementation. Polymorphism. Polymorphism means many forms. The same method name can perform different operations depending upon the object or context. This improves flexibility, code reuse, and maintainability. There are the major phases of OOAD includes requirement specification, analysis, design, implementation, testing, deployment, and maintenance. These phases help ensure systematic software development. Throughout this course, you will learn software process models, requirement engineering, UML modeling, object-oriented analysis, design modeling, testing, deployment, and software implementation techniques. You will also gain practical experience through laboratory exercises and project development. The laboratory session will focus on requirement specification, UML modeling, interaction diagrams, state diagrams, and complete software development. Students will work in teams to develop real-world software application. Suggested application. Several project domains are suggested, including ATM management system, library management system, hospital management system, online banking system, and e-learning platforms. Student team can choose any one without repetition from the above mentioned applications. From a placement perspective, today's concepts are extremely important. Questions related to classes, objects, abstraction, encapsulation, inheritance, polymorphism, UML diagrams, and software development life cycles are frequently asked in technical interviews, coding assessments, and software developer recruitment processes. A strong understanding of these fundamentals will help you build a software foundation for advanced software engineering and system design topics. To summarize, we discussed the need for object-oriented analysis and design, understood classes and objects, explored the four object-oriented principles, and reviewed the course structure. Thank you and see you in the next lecture.